So there's two words that I'm going to use here, the word read and the word write. So DNA polymerase is reading the parental DNA. It's reading it. And what I mean by that is this enzyme is going to look at the parental strand, for example, right here, and say, okay, here's an A. So what do we need? Well, we need a T. And then the DNA polymerase is going to write T. And then it's going to read C, and it knows that it should write G. So DNA polymerase is reading the parental strand, and it is writing the new strand. Okay, so you with me on this? So it's reading the previous strand, and it's writing the new strand. Here, the DNA polymerase is going to read the parental strand, and it's going to use that information to write the new strand. Just like if I asked you, what's the next letter here? What's the next letter here? What's the next letter here? You would read these letters and you would write the new letters. Now, here's the thing about DNA polymerase. DNA polymerase can only read in the 3' to 5' direction. What does that mean? That means DNA polymerase can only move from 3 towards 5. And it can only write 5' towards 3'. DNA polymerase can only add nucleotides to the 3' end of the new DNA strand. Now, for the top half of this molecule, that's great because we're actually moving overall, we're moving to the left. Our overall direction of replication right now is to the left. We're pulling apart these parental molecules, and overall, we're building to the left. We are on the left side of this bubble right here, okay? Everything's going good. Now, here's the problem. We're moving to the left, so this DNA polymerase wants to go to the left. However, it cannot go to the left because that would mean DNA polymerase would have to read the 5' to 3' direction. DNA polymerase cannot read that way. DNA polymerase can only read 3 to 5. So these DNA polymerase molecules here, they can't move left. They can only move right. But overall, we need to move left. So what do? Well, they do this really interesting little pattern where if you can follow my mouse, they start here and they read to the right and they build to the right. They are reading from the 3' to the 5', and they are writing from the 5' to the 3'. And then the DNA polymerase will disconnect and then join again over here, further to the left. And then it will move to the right again, reading and writing, until it finds where it left off. Then it will break off again, and then it will join here and move to the right, reading and writing. And then when it meets the part that it already finished, it breaks off again, and joins here, moves to the right, reading, writing. So you can see this process. In order for DNA polymerase to move to the left, it has to actually move to the right, then break away, connect to the left, and then work to the right again. And that's because of these primes. DNA polymerase can only move from the 3' to the 5' direction. It can only read 3' to 5'. So this top strand, since there's no issues, since the DNA polymerase can follow the replication fork, which is moving to the left, we call this the leading strand. But this other DNA polymerase that has to move to the right and then break off and then move to the right and then break off, we call this the lagging strand. And the lagging strand, these little pieces here, these are called Okazaki fragments, discovered by a Japanese biologist named Okazaki. And these DNA ligase enzymes are going to glue together these Okazaki fragments. I think a video can really help you understand this concept.